Hello dear students, in this lesson we are going to talk about roots. First of all, let's try to understand what exactly are the roots. Students, just like addition and subtraction are opposite to each other, similarly multiplication and division also are opposite to each other. And in the same way, we can consider powers and roots also to be opposite or inverse operations. Now, let's try to understand first. Let's say we have an expanded expression for an exponential form. Let's say 2 get multiplied for 5 times. So we can represent this as 2 raised to the power of 5. Or I can also say that 2 raised to the power of 5 is equal to 32 when I simplify that. So students, in other words, I can also say that if I take the fifth root of 32, that's gonna be equal to 2. So the theory is roots and powers are just the inverse operations of each other. Let's take a few more examples. Let's suppose, students, we have got a number 4 raised to the power of 3. It simply means 4 has to be multiplied for 3 times, and as we multiply it for 3 times we get 64. So I can say that, okay, 4 raised to the power of 3 is just equal to 64. So in the other word, I can say that, okay, third, just because it's the power of 3, so if I consider the third root, basically, third root of the number that we have got here, that is third root of 64, is equal to the base that we have multiplied. So just power and roots are just the inverse operations of each other. Let's take another number. Suppose I have got 8. Let's take some other number. Suppose I have got 7 raised to the power of 2 is equal to 49. As you know that 7 times 7 is 49. So you can also say that second root, students. So we don't often write the second root. I will let you know why. But for now, let's write it as 2 here. But we don't need to actually write it. There is a reason behind that I can explain later. For now, the second root of this 49 equals 7. So students, these 2 and 3 powers have some specific names. Whenever we raise to the power of 2, it's called a square. So instead of saying 7 raised to the power of 2, we could have said 7 is squared. And similarly, we could have said 4 raised to the power of 3, and as well as we can say that 4 cubed equals 64. So we'll be learning these two new kind of powers. Basically, these are just specific names for these two particular exponents, 2 and 3. So 2 is said to be squared, 4 is said to be cubed, and that will be learning. And opposite of a square is called a square root, and opposite of cube is called cube root. So we'll begin with a square. First of all, what exactly are the square numbers, and then after we'll also learn how to get the square roots. So square, students, as I mentioned, that whenever we multiply a number to itself, means it's gonna be having a power of 2. It's simply called a squared number. Let's say 4 has to be multiplied for 2 times, so we would say that 4 raised to the power of 2, or 4 is squared, and it means that 4 get multiplied to itself. And similarly, we can have any number. It could have, suppose it could have been 7 is squared, then you would say 7 times 7. 7 times 7 is just 49. So the idea is, whenever we raise a power of 2, that is called a square, and we say that that particular number is squared, and whatever is the result, that we can write at the other side. So at the beginning, students, you need to memorize a few square numbers, because when we multiply number to itself, whatever number we get here, these numbers are said to be the square number, not those numbers whose got squared earlier. Basically, the numbers which are being squared and the numbers that we get as a result, these numbers are called the square number. Just like 1 times 1 is 1. So 2 is not a square number. Basically, 4 is a square number, because 4 is obtained by multiplying 2 to itself. Similarly, the next square number is 9, then 16, then 25. So initially, for you guys, it's sufficient if you can memorize up to 15th. So up to 15th, we have these many numbers. The square of 6 is 36, then 49, 64, 81, 100, 121, 144, 169, 196, and 225, students. This is how you can memorize these square numbers. And why these are called square, students? Because when we arrange them using these blocks, they will form a kind of a square of the similar length that we have multiplied. Just like here, 1 squared is 1, 2 squared is 4. So if you keep 2 squares together, 2 times 2, that's 4. Similarly, if you make a square of 3 units, that will give you 9. So this is the kind of physical interpretation of a square number. So you can memorize them, and that will be very useful. So students, these numbers that we discussed right now are also called perfect square numbers, because those numbers are obtained by multiplying a whole number to itself. Whenever we multiply a decimal number to itself, it can also be squared, but we don't call those results to be perfect square. For example, if I multiply 4 times 4, it's obviously a whole number that becomes 16. So this 16 is a perfect square number. This is a perfect square number. But at the same time, students, let's say if I multiply 1.2 to 1.2, it's again a kind of, it's still squared. We would say that 1.2 has been squared, and when we solve them we get 1.44. So this number is not a perfect square. So perfect squares are obtained by multiplying simply whole numbers to themselves. So this is how we call them as perfect square or non-perfect square. Now students, let's try to understand what happens when we square a negative number. So students, you guys know that squaring some number is simply means that we are gonna multiply it to itself. So even if it's negative 5 squared, students, it simply means negative 5 get multiplied to itself. But students, you know that whenever two negative numbers back to back multiplied, they become positive. Negative times negative become positive. So the answer will remain positive, just like negative 5 times negative 5. So both the negative become positive here. And of course, if there was a positive number, that would still have been positive. There is no case of negative number. But remember, even if we have a negative number squared, that remains positive after multiplication, because negative times negative is positive. Just one more exception is there, students. If the negative sign, let's say we are given negative 5 whole squared, that's obviously negative 5 get multiplied to negative 5, and we get positive 25. There is no doubt about that. But for example, we are given negative and then 5 squared. Right now you notice that this square hasn't got anything to do with this negative sign. It means that the negative sign is kept outside, and we are only applying a square on this 5. So we keep this negative as it is outside. However, this 5 got squared, so it means that this 5 has to be multiplied for 2 times, and the answer is negative 25. This is an exception because this negative sign wasn't included within the square. That's why we did not consider that in multiplication. If it was in the bracket, we would have considered that to be multiplied, and then we would get the positive answer. This is how we can get the square of any negative number. After that, students, let's try to understand how do we get a square root. So as you guys already have memorized, or you will memorize them, so once you know the square numbers, you know what are the square of certain number, you can easily get its square root. For example, if you know that a square of 15 is 225, so if you have been asked to get the value of a square root of 225, it's nothing but 15. And students, we don't write 2 here because it's understood, because single root doesn't exist. So it's a waste of energy and time. Why do we write this 2? Because single root doesn't exist. It won't exist ever. Therefore, we even don't write this 2. But yes, later on when we'll be learning cube root and other roots, at that moment we'll have to write them. So for now, you could have even written it like just this is called radical symbol though. You can memorize, it's called radical symbol, and using this radical symbol also it's fine. So the square root of 225 is 15. Similarly, students, let's say we have got let's say 12 squared is 144. So if you want to represent it as a square root, you would say square root of 144 equals 12. This is how we can consider. Now there is one more theory, students, that we get positive and negative both the numbers whenever we get the square root. But at your level, you are not supposed to understand that. Simply you imagine that to be the principal square root, and in your higher grades you will be learning what happens with positive and negative signs. But for now you don't have to worry about that. You simply consider a square root to be a positive number. That's sufficient for now. After that, students, just like we discussed the square numbers, we can also discuss about the cube numbers. Just like a square number get multiplied twice, means the number multiplied to itself, it's called a square number. To get a cube number, a number is multiplied to itself and then again itself. So basically the multiplication takes place for 3 times, okay, and that type of number are called cube numbers. Just like if it's 4 raised to the power of 3, it means that 4 got multiplied for 3 times, and when we simplify this we get 64. So 64 is a cube number, okay. And again, you can at least memorize at least 10 initial cube numbers. Again, these numbers that we are multiplying are not the cube numbers. The result that we get after, that is called the cube numbers, like 1, 8, 3 get multiplied to 3 times, it becomes 27. So 27 is a cube number, 64 is a cube number, and so on. 125, 206, 343, 512, 729, and 1000 when we cubed 10. So students, again, just like we consider any number, suppose it's 20 and you want to get its cube, what you will do, you will simply have to multiply it for 3 times. So 20 times 20 times 20, and you will be able to get a cube number in that case. First you multiply these 20s, 2 20s, it becomes 400. You further multiply this 20, it becomes 8000. This is how we get cube of any number. And again, students, physically if we consider, it's just like a cube of the similar side. If you're getting the cube of 3, it means that there is a cube of a side length of 3 units, and if you just count the number of blocks, you would get 27 inside that. So physically you can understand a square and cubes, so they are somehow related. Apart from that, we can also discuss how do we cube a negative number. Just like we used to we learned how do we square a negative number, in the same manner we'll also learn how to cube a negative number. So students, just like let's say we have negative 5 raised to the power of 3. So right now the multiplication takes place for 3 times. So once you multiply 2 negative 5s together, that definitely became positive, because negative negative became positive 25. However, there exists another negative sign that get multiplied, and after this multiplication it remains negative, because positive negative multiplication will still produce a negative result. So remember, a cube of any negative number is still negative, while a square of a negative number is positive. That's a different case. So that's a simple idea about your cubing a negative number. And yeah, after that we can discuss what exactly is a cube root. Just like we discussed cube numbers, so their opposite is cube root. And by now you must have seen a few examples that we discussed. For example, if we have cube of 3, that's 27. So if you want to get a cube root of 27, so you would write, okay, 3 is now the radical. Radical is symbol is there, and 3 is the index now. So cube root of 27 is 3. Similarly, let's say we have cube of 8 equals 512. So we can also write that as third root or cube root of 512 equals 8. So you can now realize that cube and cube roots are just the inverse operations of each other. So in general, students, if you raise any number to certain power, let's say you have any number It could be say 8 raised to the power of anything. It could be 4, for example, or it would be a bigger number. Let's say take a simpler number, say 3 raised to the power of 4. It gives you 81 when you simplify. So in the same question, in the same expression, you can represent that as a root. Now just because the power was 4, so the root will also have the index of 4. So fourth root of this result is equal to the base that you have got earlier. So this is the simple idea about power and power root. You can go through these examples, students. In the next class, we can talk more about different laws of indices or different laws of powers. Till then, bye-bye. Take care.